Now most of the people doesn't know internal structure or architecture of PIC. So it is not possible to take theory as well as practical lab within a day. So we will start our practical session with basic knowledge of PIC controller. So this is PIC controller. If you see the port pins, it is RB, RD, RC, RA, RE. So there are different ports. So we'll separate these pins into ports like this. So pin number 1 is reset, which requires active low signal. Pin number 2 to 7 is port A. Pin number 33 to 40 is port B. Pin number 8 to 10 is port E. Then pin number 30 to 27 port D. Again some part of port D is at pin number 19, 20, 21, 22. Then port C is 15, 16, 17, 18 and 26, 25, 24, 23. So if you see, only port B and port A are aligned, or you can say sequentially. Remaining pins, some parts are here, some parts are there. Power supply, it has two power supply. VDD means 5 volt and VSS means ground. So pin number 11, 12, pin number 31, 32, these are power supply. Then pin number 13 and 14, clock. So you can connect RC, resistor capacitor circuit, to generate oscillation, or simple crystal oscillator. Generally in all microcontroller like 8051, PIC, ARM, APR, we are using crystal oscillator. So we'll keep that habit for PIC also. So you have to connect oscillator here. Oscillator is very important. Without oscillation, it will not execute any instruction. In PIC controller, Harvard architecture is there. There are two types of architectures, von Neumann and Harvard. So in Harvard architecture, there is separate memory for program and separate memory for data. So at a time you can access program as well as data, and therefore the speed will become fast. So this is the basic structure, or you can say pins for PIC controller. So in PIC controller, if you want to execute any circuit, add some power supply. So first part is power supply. First is microcontroller itself. Second, power supply. Without power supply, microcontroller will not work. Third, clock. And fourth is reset. These four circuits are very, very important. Without these four circuits, you cannot make any microcontroller circuit. For 8051, for PIC, AVR, ARM, for any microcontroller, you require these four circuits. So first is microcontroller. So here we are using PIC microcontroller. So this is my microcontroller. Second, power supply. PIC controller operates on 5 volt. So this is my power supply. So in power supply, there is rectifier. We can connect 230 volt to transformer, then that is converted to low AC, then bridge rectifier, filter, and 7805 regulator. So this is my power supply section. Next is clock. Clock. So clock. Here you can use any crystal. If your crystal value is less than 15 megahertz, you have to use 33 picofarad capacitor. And if your crystal value is above 15 megahertz, you have to use 22 picofarad capacitor. This is the tank circuit which will generate oscillations. Now this crystal value is very important while doing the programming. You have to select the oscillator type, high frequency, low frequency, etc. So this is my clock circuit. And last, fourth is reset circuit. This is my reset circuit. This PIC controller requires active low reset signal. So when this switch is open, you are getting 5 volt, so it will not reset. And when you press this button, then it will reset. So this is the basic circuit of PIC. if you see board, this is my basic PIC board. In this PIC board, this is my microcontroller, this is my power supply section, then this is my clock, crystal and 2 capacitor, and this is my reset circuit. And all pins were taken outside, and there is one LED which is connected to RD2. So green LED is RD2. We can use LED blink program to test this board. So this is my basic PIC board. Using this PIC board you can make any system. And to load your program into this PIC board you require programmer. So this is my program. PIC kit 2. This is my programmer, PIC kit 2. So it can be used as standalone programmer as well as in-system programmer. If you put IC here, then it is standalone programmer. And if you connect this connector, to your board like this, then this will become in-system programming. So I will show both demonstration. But without this PIC kit 2, you cannot do real application. But in Proteus, you can execute your application and you can run that part. So this is the hardware, and if you want development board, this is general basic board. But if you want development board, then development board is also available for PIC. So this is my PIC development board. So this is PIC development board. You can perform any lab or practical on this board. So there are different types of boards. Today we can perform lab on this board as well as on this board. But for both this you cannot execute any lab. So my intention for today is to give you practical knowledge on real application as well as on simulation. So if you have any doubt, you can disturb me. You can. So we are using adapter here. So power supply will be given from adapter. Then pins. So these are different pins, port pins. These are different port pins. So first see this pin diagram. Now I want to do the coding of this. PIC controller, reduce instruction set. So only 34 instructions are there for PIC. That instructions are assembly language instructions. That instructions are for assembly language instructions. Any microcontroller, 8051, PIC or AVR, they operate only on assembly language. But we had designed compiler or IDE which operates on high level language, C language. Today we are going to learn high level language, that is C language for PIC. Again, same C language, by some changes you can use this for ARM processor. Very important to execute or perform the practice. So what basic requirement you should know for PIC microcontroller for doing the lab? So you should know how many pins are there. So there are one 6-bit port, that is port A. It is 6-bit. Then there are 3 8-bit ports, port B, port C, port D, and one 3-bit port, port E. So if you count the port pins, port A is 6, B, C, D are 8 and E is 3. So 8 plus 24 plus 3. 6 plus 24 plus 3. So it is 33. If you compare with 8051, 8051 has 32 input output. Whereas A, B, C, D, PIC controller has 33 input outputs. Now in this, most important part is port A, which is pin number 2 to 7, and triacs A. So triacs register is very important. Without knowing triacs register, you cannot do any application. So for each port there is one triacs register. So port A, triacs A, port B, triacs B, port C, triacs C, port D, triacs D, port E, triacs E. So triacs is very important. Without knowing trias, you cannot do anything. So what is trias? So trias register is used to set the direction of your port, whether your port is input or output. Same like in Arduino, yesterday we had seen, in setup code you have to write the code, pin mode, pin number, input or output. So that is done in setup. But in PIC controller using trias, you can set that pin as an input or output. So trias is very important. Using trias, you can make any pin as an input or output. And remember, these all ports are bidirectional. And you can make some part of pin as input and some part of pin as output. So port A, you can make input as well as output. But for that you require trias register. And the trias coding is very simple. If it is 0, then it is output. If it is 1, then it is input. So we'll see port and trias register. See, so this is my microcontroller and this is my trias register. So trias register, if it is 0, then that pin is output. If it is 0, then output. 1 means input. 1 means input. So you can make some part as an input, some part as an output also. So this trias and port. So if you are using trias A, if you are using port A, then it should be trias A. If you are using port B, then it should be trias B. If you are using port C, then it should be trias C. If you are using port D, then port D, trias D. If you are using port E, then both should be E. So this is very important. Without knowing trias, you cannot execute any instruction in PIC, any program in PIC. So any doubt regarding trias and port? Don't know what is PIC controller, what is the internal in PIC controller. Like yesterday we had done the practicals on Arduino, but we don't know what is the internal in Arduino or a AVR microcontroller. Similarly, today we are going to take hands-on port is port A, and 8-bit ports are port B, port C, port D, and 3-bit port is port E. So total 33 input outputs are there. So to make any port input or output, you have to use trias register. And in that trias register, you have to load 0 or 1. So that trias register is very important. Without trias register, you cannot initialize any port as input or output. So take example of this. Here, this trias register will set the operation of, if it is 0, then output, and if it is 1, then input. Suppose I want to make this first pin as an input, then it should be 1. So trias 1, and then it should be input device. If you want to make it output, then trias bit should be 0. Similarly, we will take example for port A.